Hi, my name is Xinzhi Zhang. I participated in Google Summer Code 2021 in MariaDB Foundation. I work on Jupyter project for autocomplete and the reactive feature. First, I mentioned the outline of in this presentation, and first is the introduction of this project. Second is to mention what do I do in this project. Third is to talk about the difficulties I encountered in this project. Fourth, to discuss two types of completion engine, mention their advantages and disadvantages. And fifth, I talk about the auto completion engine I created for fix some disadvantages in the MyCLI's auto completion engine, and the completion engine is use the SQL Pulse, and the SQL Pulse has many defects. Okay. Next, introduction of this project. This project is on Jupyter Notebook kernels. Jupyter is a powerful programming tool that can interactively coding and like a notebook. The target of this project is to bring auto completion and the introspection feature into MariaDB kernel. Auto completion, in my opinion, is well known for anyone who has coding experience in SQL, such as select the column from MySQL.user, and the word start with PA. It will show a suggest a column named password, and another feature introspection is to resolve a specific word to a type and show some related info, such as the user column from MySQL.user table. It will be char 80 type, and will show first 5 rows of this column. And this project autocomplete feature is based on popular Python package MyCLI. MyCLI is a powerful MySQL auto completion toolkit on terminal, and I would integrate it with MariaDB kernel and do some enhancements on that. Next, the design of this project. There are 4 components. SQL Analyze is responsible for analyzing the SQL statement and providing a function that inputs the SQL statement and the text cursor position, then gets the suggestion. For example, use get suggestion function on SQL statement like this, and at the tab position will get a list of suggestions. It contains object has 2 fields, text and type. And in this case, all the suggestions is database type. And there are information schema, MySQL, performance schema, test. And the next component, SQL Fetch, is responsible for providing convenient function for fetching data, such as provide a database function that will return a list of database names that are currently DB's databases. For example, return information schema, MySQL, performance schema. Next component, AutoComputer, is responsible for simplifying the use of SQL Analyze and SQL Fetch. It will provide two functions. One is a refresh function. They can refresh the DB's info in AutoComputer. And the refresh way can decide to be sync or unsync. And another is get suggestions. It will get suggestions based on text and the cursor position. For the example, the refresh function must be called after execute SQL command. And if a region database DB metadata is not empty, and after execute this kind of SQL command, then call refresh function will update the DB metadata like this. The user table contain a column. Let's talk about introspector component. The introspector is responsible for providing an inspect function that can given text and the cursor position, and then return the HTML that will be shown to users. For example, use inspect function on SQL statement like this, and add a word mark green. User will return a string like this, show the column type and the first 5 rows of the column. Later, we'll mention the relationship of these 4 components. AutoComputer uses SQL Fetch to update the data inside SQL Analyze, and such as update DB metadata. So in SQL Analyze, we need to suggest tables in the currently selected database. It can find in DB metadata. Introspector use AutoComputer because it needs to share the data that the AutoComputer's SQL Analyze has, and use AutoComputer's SQL Fetch to get some HTML, such as when inspecting the word type is table, need to get a table schema HTML to show to user. Next, talk about what do I do in this project. This part I only show the demo of what I do, not explain the internal implementation. The first contribution is to create the 3 components: AutoComputer, SQL Analyze, and SQL Fetch, which described before. And in AutoComputer, its refresh function can be async. It will create a thread to do refresh work. There is a video demo. So I press the tab, and it can show a list of suggestions. And the second is to mention a list of enhancements based on my CLI's functionality. First is my mentor and I implement new information schema tables on my MariaDB server. So in this project, AutoComputers can use the command to get the table's data. So I can automatically fetch the latest keyword in the function list, and it will be provided on auto-completion. Second is database suggestion before Dart. There is a video demo. You can suggest all the tables when Dart and you can constrain the database to suggest, like after Dart is T1 table, and before the Dart, it will suggest only the database contain the T1 table, not the all. And the third is enhancement of database table column suggestions. There also has a video demo. Some kind of SQL statement like insert into in original MySQL elect database suggestion, and I do enhancement on that, so it can provide all the database name. And the fourth is the add global and the session variable suggestions. Global and the session variable is start with to add symbol, and I can provide a suggestion for them, and there are differences. So, has global and the session type. And the fifth is to remove the auto-completion suggest current name from statement like this. Because in this project, the introspection will provide the current hint. So auto-completion will not be necessary to provide current name after place like this. And there is a demo. So I press the Shift E, will show nothing. And the sixth is to fix some bugs related to the name user, which is a current name, also a keyword. And my CLI encounter this kind of situation will provide run result, such as SQL statement like this. User will be recognized as keyword, not column, in SQL Plus, and my CLI in this situation will suggestion a list of user name at a tab position. This is wrong. It should suggest a column name or function name in this position. And the third is introspection feature. And the most basic introspection feature is for introspect database table and the column, and it will show related info on them, such as database will show which tables it contains. The table will show its schema and the partial table rows. For column, it will show the data type is stored and some data in this column. There is a video demo. So I introspect my SQL database. It will show all tables in the SQL database. And the introspect table will show the data type and the partial rows. Inspect column will show its column type and the first 5 rows of this column. And when inspect other type of word, such as keyword, and so on, it will show nothing. And the fourth is introspect function will show its documentation. There is a demo. And the fifth is introspect user keyword will show user lead, like this image. And the sixth is column hint. It will show when insert into table after values left parentheses, and it has two cases. One is no mention column list, another is mention column list. It will show corresponding column name and its type. So user can know the place need to fill here is which column, and which type. Next, talk about the difficulties of these projects. First is about SQL Pers limitation and it result into MySQL is difficult to resolve or to specific type because SQL Pers is Pers result like this. The name token can be function, column, or table, and so on. And it cannot be resolved in more detail type. So this is a problem. And MySQL and the MySQL look at the Pers tree, resolve name to more specific type such as database, table, column. For example, there are a statement. We need suggest type after mini. The token before the cursor is left parenthesis. So we need to consider 5 cases. These 5 cases is under the condition is top levels less token is punctuation left parenthesis and have their own conditions. First, check the top levels less token is where instance, then look at more cases. Here is not discuss that because internal has more cases to check. And the second, check the top levels token than the previous the token before the test cursor. And check it is using keyword or not. If it is suggest column, and in this case it is mini left parenthesis. So check the top levels. First token is selected or not, and the last word is just left parenthesis. If it is suggest keyword, because it is a subquery, maybe after the left parenthesis is select keyword, and so on. False. Check the top level first token is show word. If it is, suggest a little special keyword after show. And fifth is not above cases. It will be in simple function code, so suggests column. In conclusion, MySQL suggestion is multi-option in most scenarios, but the introspection needs to resolve to the specific type. There's a way to solve this problem is looking at the database info. For example, the suggestion in column 1 will be column, key function or keyword or alias. We have special result order. So first we check is it column or not. We look at DB metadata tables field. Find in current database DB1 have table name table1 or not. If it is, then check in the table has column 1 or not. In this example, there is column 1, so this word is a column. The introspector will get list, and the introspector will get list. Word column 1, type column, database is DB1, table 1. And if not found, we'll check the next suggestion type in the priority. And the MyCLI suggestion column function keyword alias, the next in the check priority will be function. First is column, second is function. But there is a problem. If there is the same name be multiple types, it may result to the wrong type. For example, if table 1 has a column name named mini, and there is a function named mini, the word mini will be recognized as a column in the check priority because column is higher priority than function, so this will be resolved to column. And in order to fix this, I need to do small check on that. In these cases, we'll check the next token after the cursor is left parentheses or not. If it is left parentheses, it will be function. And the check priority is also important. For example, if the check priority is a green one, then user word will be resolved to keyword. Because there has a column, user column in MySQL.user table, and the user is also a keyword. Keyword is higher priority than column in the green rule. So in the right check priority, it can solve most of the wrong cases, like the black one. Column is higher than keyword. This is because MyCLI it suggests more type than actually can use, especially for keyword and function. So reduce the priority on len can resolve many wrong cases. And we do previous request enhancements, like more check. They can remain very little wrong cases. Next, discuss two types of computation engine. Now, I will talk about the comparison of two types of auto computation engines. One is to use the handwriting parser. If this kind of parser maintained by the compiler or interpreting, then it is fine to use it to implement the tool about auto-completion. Go to a definition and so on feature. But if it uses the parser like SQL parse, which is not maintained by original team, the real-world parser, because the real-world parser is very complex, so SQL parse has many defects, such as this doesn't match the real-world database grammar, and it commonly parse the wrong result, like the case I show here. The left is the SQL statement, and the right is the parse result. And the place I mark the green line, it will be recognized as function. This is wrong. It should be table name and then column list, not a function call. And the handwriting parser is hard to match the parsing process with the grammar rule. Second type of auto-completion engine is use the auto-generated parser like Bison, and you use this kind of parser for implement the auto-completion. And if the grammar fit into Bison is complete, then the parse result will not be wrong. Can make sure it covers the whole grammar and nearly no error. And the MariaDB is maintain the SQL yacc.yy file in SQL folder. It can be used and can have the same parser with the MariaDB SQL database, and we can easily annotate something to parsing process and get the information that helps a lot in auto-completion. And in final, I talk about the auto-completion I create. This is experiment part, and it's still on progress. There are three main components: Lexer, cursor, coder, Bison XML reader, and the auto-completion engine. Because our project is using Python, but the Bison generated parser and the Lexer is written in C language, so I need to build a .so file for Lexer and create a Lexer coder to load the library file and execute it to get a list of tokens. And I will need to annotate it into info at parsing process. So I create a Bison XML reader XML report, get the LR1 parsing needed info like go to table and the action table and so on. So I can parse on them. If we parse the statement at the left, then we get the result at the right. And in this example, I only show the name token, so I can, based on the token match row number and the match index to deduce it should be database, table, or function, and so on. Such as the word customer in match on rule 45 table factor, and in this rule, and it match on the 0 index. So we look at the 45 grammar rule table factor. The first token to be matched would be a table type. So we can resolve the customer into table type. This way, we need to annotate all the grammar rule that contain name, token, and its position. So when get a type from list of tokens, we can look at the dictionary to get the type it should be. And the previous describes is complete SQL statement is for existing word. But auto completion is predicate the next token, which is not existing. So in the Bison report, it has many transition. The type left is to predicate the next token. It may be to B, and the go to type is to reduce the token bit shift and make sure this totally match one grammar rule, so it can reduce to specific type, such as if there go to on 223 grammar rule, it will be reduced to expression. And in these cases, for predicate, after passing to the predicate, it will be in at one passing state 25. And in 25, there is many transitions like the image here. The name symbol, if it is a name symbol, it will be state to state 51, and in state 51, there has many rules. Name token is shift name token, and we can look up the dictionary to get this name token is which type, such as the rule 221. The name token will be column, and 223 will be the first name is table, second is column, and the rule 264, the first name token will be function. So in the transition for the symbol name, it could be current function in the table, and in the remaining transition, they will suggest this kind of keyword. So this auto completion is very powerful based on grammar. It only provides the token, the type, they will be valid in the statement. It will not provide the word, they cannot be used in here. And the best part of it is not to maintain a handwriting process to the very complex grammar. It can auto-generate process and only annotate which rule name token is what type, and we could only automatically update to latest auto completion feature. But this auto completion engine is still in early age, so it is not adapted in this project. Okay, thanks for watching. My presentation is end.